Hello and welcome to the 4th International Forum of the Global Strategy Institute at KAIST on Digital Big Bang Metaverse Technology. We're coming to you from KAIST main campus in Daejeon, Korea, and streaming live on YouTube. My name is Scott Gabriel Knowles at KAIST, and I'm a faculty member of the Graduate School of Science and Technology Policy. I will be your moderator today. The Global Strategy Institute was launched in February of 2020 as a representative think tank of KAIST, providing insight into global and national issues using our expertise in science and technology. We held 3 international forums on global cooperation in the coronavirus era, envisioning the future of education for non-contact society in the post-coronavirus era, and post-corona, post-human, medical and bioengineering revolution in April, June, and September of last year. Today, we're excited to have top experts from all over the world joining us for our 4th forum. We would like to learn about the development trends of immersive technologies, such as Metaverse and AR/VR, innovative, emerging technologies solving various problems caused by continuing non-face-to-face society. Global experts will discuss the development and potential of technology together and predict the future of society. It is my great pleasure to introduce you to the president of KAIST, Dr. Kwang-Hyun Lee, for his welcome remark. When I had a conversation with the president before, I learned that he prefers to take on new challenges others have yet to attempt, and that he's a strong advocate of boldness and creativity. Sometimes he places the TV or even the KAIST organization chart upside down, like this, to obtain new perspectives and inspiration for innovative ideas. This is how we find creative solutions, by viewing problems from completely new vantage points. I hope you enjoy this forum, full of unique ideas and creative opinions on how we can construct new virtual spaces and connect them to the real world. Thank you, President Lee, for coming. Welcome to this forum.
Hello, everyone. Welcome to the 2021 Global International Forum. Thank you to the distinguished speakers and participants across the world for joining us online. I deeply appreciate your participation during these trying times. Especially, I would like to thank the Minister of Science and ICT, Jesus Lim, for delivering her welcoming remarks. I would also like to thank Director Son-Hoon and his team for making this forum possible. Since its opening last year, the GSI International Forum has reflected the most challenging global issues we have faced during the unprecedented era. Here, at the virtual KAIST stage, we will discuss the present and future of Metaverse technology. This forum will also explore how new technologies affect the education sector and beyond. These new technologies are truly opening a new horizon for our lives. The pandemic has opened up a new window for innovations that came into existence only a few years ago. Unprecedented demands for non-contact service are driving up digital innovation everywhere. what we are witnessing is a digital big bang. In the education sector, digital technology will also create new opportunities to resolve the long-standing pedagogical shortfalls of one-way knowledge delivery systems. New digital technologies will help to unlock the creativity of our students. Education tailored to students' level will not only help them accumulate knowledge, but also improve their ability to use it. Universities around the world are now at the same starting line. We need to innovate new approaches that can enable all sorts of campus activities and learning experience online. KAIST has already started to prepare for this new world. We have launched new initiatives for Metaverse technology. For instance, we created the Metaverse ASI Creator Program for Metaverse planners, developers, and designers this year. We will team up with the SM Entertainment, a leading global K-Wave company in Korea, to collaborate on diverse Metaverse technology development. This is a KAIST icon. I like to feel that. I look forward to your discussion and deep insights inspiring us to reshape the future of our lives, especially our education sector. Thank you very much.
Thank you very much, President Lee, for giving us these excellent welcome remarks. I would like to take this opportunity to thank you for supporting our GSI International Forum. Our next guest is the Minister of Science and ICT, Republic of Korea, Hae-suk Lim. It is my great honor to introduce you to the Minister for her welcome remarks. Welcome, Minister Lim.
Greetings to everyone. I'm Hae-suk Lim, Minister of Science and ICT of the Republic of Korea. It is a great pleasure to deliver congratulatory remarks at this international forum organized by the KAIST Global Strategy Institute. I would like to express my deepest appreciation to everyone participating in this forum, whether you are joining us in person or virtually. I'm also grateful to KAIST President Kwang-hyung Lee, GSI Director Hun Son, and everyone who has played a part in organizing this forum. The fourth GSI-IF provides a golden opportunity to discuss various topics regarding the metaverse, which I believe particularly important to prepare for an innovative future of science and technology. With the advent of the COVID-19 crisis, the world had been abruptly thrust into a non-contact society. This has made online learning and remote working a new normal, yet it has also given rise to several side effects that are worsening day by day. For example, we can look at how the transition to online learning has decreased the effectiveness of education. According to a study on the educational achievement gap in 2020, as a result of COVID-19 in South Korea, the transition to online learning has resulted in a smaller number of students performing at the median level in their courses compared to the year before, in 76% of middle schools and 66% of high schools that were surveyed. It is imperative that we redefine the core values of non-contact society to minimize such negative side effects. Through a keynote speech I gave at the Global Emerging Technology Summit, hosted by the U.S. National Security Commission on Artificial Intelligence on this July, I defined the non-contact society of the future as a next-generation networking era. As the world develops and advances, new information and communication technologies, I believe we will be equipped with the tools and means to minimize the negative side effects of today's non-contact society. Furthermore, as the non-contact society enters a new era, people will readily engage in educational, cultural, social, and economic activities. Most notably, scientists and engineers will play key roles in the next generation networking era. With Korea's experience and expertise in 5G technology, being the world's first country to launch a commercial 5G network, I'm confident that our scientists and engineers will develop innovative and top-class technologies that can be appreciated around the world. In this forum, we'll discuss Metaverse Technology, which is emerging as an innovative solution for the next generation networking era. People expect that the Metaverse brings big changes to our lives as a core part of the economy and society within the next few decades. The Korean government views Metaverse technology as a catalyst for future growth in the changing market landscape. With this in mind, the government is seeking to support the development of relevant industries through policies such as government-private partnerships, R&D investments, personal trainings, and regulatory improvements. In July this year, the Korean government announced a roadmap to support and foster new future industries, including the Metaverse, through the Digital New Deal 2.0, a national innovation project spanning across all government branches. As a next step, the Ministry of Science and ICT is going to actively support innovation in the private sector by establishing an open metaverse ecosystem in which a wide variety of companies can take part and develop new content and services. With this in mind, it is truly meaningful that the fourth KAIST GSI-IF is centered around the subject of Metaverse technology. I hope that this forum can lay the foundation for global cooperation so that we can establish a Metaverse ecosystem together to realize a non-contact society that does not restrict, but rather enhances our daily lives. Once again, thank you all the speakers and experts from leading organizations and the audience from all around the world who are participating in this forum online. May this forum be a valuable opportunity to proactively discuss innovative global strategies regarding the Metaverse so that entire world can enjoy greater prosperity in the post-COVID-19 era through science and technology innovations. Thank you.
Thank you very much, Minister Lim, for your thoughtful message. I would like to thank each of the opening speakers. Now, we move on to the plenary session. Thank you. Welcome everyone to this plenary session. This is Scott Knowles again from KAIST. Our session agenda is Metaverse Platform and Virtual Reality. Our first speaker is Mr. Ki-dong Bae, Metaverse One Team, Space Video DX Business Unit of KT. Managing Director Mr. Ki-dong Bae will introduce KT's Metaverse and immersive technology and discusses the use and scalability of these technologies.
안녕하십니까. KT 엔터프라이즈 부문에서 근무하는 백이동 상무입니다. 먼저 카이스트에서 저명한 사학분들을 모시고 진행하는 글로벌 포럼에 초대해 주셔서 영광스럽게 생각합니다. 근본 포럼 주제가 메타버스 빅뱅과 메타버스 기술입니다. 저는 첫 번째 토픽으로 KT 메타버스 비즈니스 사례와 XR 기술 자료를 준비했습니다. 최근 메가 트렌드가 되고 있는 메타버스 시장 분석 그리고 KT 사업 사례와 실전 기술에 대해 말씀드리고자 합니다. 목차는 보시는 바와 같습니다. 첫 번째로 메타버스에 대한 정의와 시장 트렌드를 먼저 살펴보겠습니다. 올해 들어서 메타버스에 대한 관심과 언론 보도가 가히 폭발적입니다. 메타버스에 대한 정의는 매우 다양합니다만 KT는 메타버스를 이렇게 정의했습니다. 현실 세상과 가상의 세상을 디지털화하여 사회, 경제, 문화 활동을 하면서 가치를 창출하는 세상입니다. 현실은 기술의 발달로 점점 디지털화되면서 가상화되고 가상 세계는 현실을 복제하면서 현실 세계와 융합되고 있습니다. 메타버스를 구성하는 요소를 살펴보겠습니다. 먼저 가상 공간이 있고 아바타가 있으며 유저들과 소통하고 거래하는 경제사회 활동이 있습니다. 메타버스는 VR, AR 등 XR 기술을 통해 시공간을 초월한 가상의 환경을 제공합니다. 메타버스 세상에 자신이 직접 참여하는 것처럼 느끼게 되는 몰입감과 실시간 상호작용을 통해 사용자에게 실제로 존재한다고 느끼는 현존을 제공합니다. 다음은 인터넷과 메타버스를 비교해 보겠습니다. 과거 유선 인터넷 시대에서 모바일 스마트폰 세대를 거쳐 5G XR 시대로 발전하면서 연결과 이동성이 좋아졌습니다. 그리고 메타버스는 사용 편의성, 상호작용성, 화면과 공간 확장성 측면에서 우월하고 나날이 진화하고 있습니다. 이는 웨어러블 디바이스 발달과 3D 공간화 기술이 뒷받침하고 있기 때문입니다. 일각에서는 메타버스가 일시적인 유행으로 끝날 것이라 보는 시각도 있기는 합니다. 하지만 세대별로 보면 인구의 3분의 1을 MZ세대가 차지하고 있는데 이들의 디지털 활동량은 제일 많습니다. 디지털 세상에 익숙한 디지털 네이티브들이 미래 구매력과 소비력을 갖추게 될 것인데요. 미래에도 메타버스 산업이 지속 확대되고 가속화될 것이라 보는 이유이기도 합니다. 메타버스 도입 유형은 크게 두 가지로 구분할 수 있습니다. 재패드 등의 메타버스 플랫폼에서 저작 툴이 구비된 환경을 활용하여 서비스하는 인플랫폼 형태의 메타버스가 있고요. 개별적인 목적에 구현되는 독자적인 마이크로 메타버스가 있습니다. 이번에는 시장의 메타버스 트렌드 변화를 요약해 보았습니다. 이용 고객 연령층은 MZ세대에서 다양한 연령대로 확산되고 있으며 활용 용도도 게임, 소셜용에서 사업 업무용으로 점차 다양화되고 있습니다. XR 기술은 기존 XR 전용 디바이스에서 가상 공간 구현으로 스마트폰과 병행해서 이용자가 점차 증가되고 있습니다. 또한 실감 미디어 사업에만 활용되는 XR 기술이 범용 기술로 다양한 사업 분야에 활용되고 있습니다. 국내 사업자를 보면 중소기업 위주에서나 대기업들이 미래 성장 동력으로 인식하면서 투자가 점차 활발해지고 있습니다. 향후에는 빅테크 기업 간 치열한 경쟁이 예상되기도 합니다. 산업군은 게임 엔터테인먼트 업종에서 비대면 사회로 전환되면서 디지털 기술이 생산과 소비, 일하는 방식 등 삶의 모든 영역으로 확산되면서 다양한 이종 산업과의 융합을 통해 적용 영역을 확대해 나가고 있습니다. 두 번째는 저희 KT 사례와 XR 기술에 대해 말씀드리고자 합니다. 2014년에 세계 최초 홀로그램 전용 극장을 선보이며 XR 사업을 시작했습니다. 이후 네트워크 기반의 VR 서비스, 도시명 VR 테마파크, 기가라이브 TV, MR 스포츠 등 다양한 실감 미디어 서비스를 제공해 왔습니다. 최근에는 교육, 관광, 국방 등 다양한 영역으로 확대하여 메타버스 사업을 활발히 진행하고 있습니다. 이 중에서 KT는 홀로그램 기술에 대한 연구와 사업화를 진행하고 있는데 홀로그램 사례를 동영상으로 먼저 보시겠습니다.
한 남성이 무대 위에 올라 이름을 부르자 미국에 있는 회장이 눈앞에 나타납니다.
예, 쟤네들 잘 계시죠?
I'm doing fine. I hope you are also.
마이클 잭슨 현정 앨범 제작 발표회에서 미국에 있는 제작사 대표와 나눈 실시간 간담회입니다. 이런 홀로그램은 공연 분야에서는 벌써 인기입니다. 30여 년 전에 세상을 떠난 유재하가 그때 복장 그대로 무대로 돌아왔습니다.
지금 동영상으로 보신 사례는 2019년 3월에 진행한 마이클 잭슨 서거 10주년 기자회견 텔레프레전스와 고 유재하 가수의 홀로그램 콘서트입니다. 마이클 잭슨 10주기 앨범 판매 기자회견은 미국에 있는 마이클 잭슨의 프로듀서인 제리 그린버그를 5G 네트워크로 연결하여 거리와 공간을 초월한 홀로그램 텔레프레전스 발전 가능성을 보여주었습니다. 그리고 이미 작고한 과거의 유명인물을 홀로그램으로 소환하여 현 시대의 동영상으로 구현하기도 했습니다. 지금 보시는 영상은 홀로그램 텔레프레전스 사례로 지난 5월 서울에서 열린 P4G 정상회의입니다. 한국이 개최하는 국제행사인데 코로나로 초청을 할 수도 없고 기존 화상회의로 솔루션은 생동감이 없어 정부가 고민하고 있었습니다. 저희가 홀로그램 텔레프레전스를 제안드려서 P4G 청년 세션을 홀로그램 형태로 진행했습니다. 서울 행사장에서 그리고 인도, 인도네시아, 스위스 등 청년들이 각 나라에서 홀로그램으로 만나 토의를 진행했습니다. 국가기후환경회의 위원장이신 반기문 전 유엔 총장님은 행사를 마치고 코로나 상황에서 국제행사를 창의적인 방식으로 제대로 준비했다고 전한 바 있습니다. 또한 P4G 행사를 기획했던 청와대 관계자는 4차 산업시대에 맞춰 새로운 방식으로 행사를 기획했고 한국이 보유한 기술을 활용하여 훨씬 생동감 있고 재미있게 행사를 진행했다고 말씀해 주셨습니다. KT 홀로그램 사례를 말씀드렸는데요. 현재 KT에서는 차세대 홀로그램 분야인 LF 홀로그램 연구 중입니다. KT 융합기술원에서는 무안경으로 실제 사물을 보는 원리와 동일하게 구현되는 홀로그램인 라이트필드 기술을 보유하고 있습니다. 라이트필드 기술은 다양한 시점에서 촬영한 3D 영상 데이터를 기록하고 복원하여 공간상의 입체 영상을 재현하는 기술입니다. 이를 통해 기존의 한계였던 초점 조절 불일치 문제가 해결되어 보다 자연스럽고 실물과 가까운 느낌의 3D 입체 영상을 제공합니다. 국내 최대 수준인 32인치까지 LF 스크린으로 구현이 가능하고요. 대학교 박물관 등 7개 사이트에서 서비스를 실증 중입니다. 이번 주제가 세미나 소재지 중 하나가 메타버스 기술들의 교육적 활용으로 알고 있습니다. 그래서 이번에 KT가 해군 사관학교 구축 중인 메타버스형 스마트 캠퍼스 사례를 준비했습니다. 해군 사관학교는 미래형 스마트 캠퍼스를 구현하고 싶었으나 좁은 공간인 잠수함 내에서 교육 인원의 한계, 서울과 진해로 분산된 강의실과 강사 등 거리의 한계, 그리고 모든 것을 직접 분해하고 입체적으로 볼 수 없는 실습의 한계를 해결하고 극복해야만 했습니다. 이런 니즈를 충족하고자 KT는 XR 기술과 모바일 엣징 컴퓨터 기술인 MEC를 활용하여 스마트 캠퍼스를 제안하였으며 현재 구현하고 있습니다. 시공간 제약은 홀로그램 텔레프레전스 강의로 구현하고 선박 구조와 분해 실습 등은 디지털 트윈과 AR 기술로 학습 환경을 제공할 예정입니다. 또한 원격지에 있는 생도들의 비대면 실시간 스포츠 코칭은 360도 매트릭스 뷰로 구현할 예정입니다. 이는 초고속 초지연이 가능한 5G 네트워크와 MEC 인프라가 있기에 가능합니다. 지금 보시고 있는 영상은 KT의 AI 기술을 활용한 G모션 기술입니다. G모션은 사람의 2D 활동 이미지만으로 3D 포즈를 실시간으로 추출하는 기술입니다. 입체적인 포즈를 추출하기 위해 슈트를 입고 촬영하면 보다 정교한 입체 이미지를 생성할 수 있습니다만 G모션은 사람의 2D 영상 이미지만으로 3D 포즈를 실시간 추출하는 기술이 특장점입니다. 현실 공간에 AR, VR 기기 없이 가상환경 체험이 가능하여 KT MR 스포츠 상품인 KT 리얼 큐브에 적용되고 상용 서비스되고 있습니다. 지금 보시는 영상은 비대면 스포츠 코칭 스튜디오에서 요가 강사의 시연 영상을 보시고 있습니다. 코로나로 그룹 스포츠가 제약된 상황에서 원격으로 강사의 동작을 따라하고 자세를 정확히 분석해주는 매트릭스 기술을 활용하고 있습니다. 영상에서 보셨던 비대면 스포츠 코칭 스튜디오를 수도권 3개소에 구축을 이미 하였습니다. 매트릭스 뷰 기술은 360도 원하는 방향에서 피사체를 보는 영상 생성 기술로서 평창 동계올림픽에서 세계 최초로 선보였으며 최근에는 무선화, 경량화하여 경제성을 확보하기도 했습니다. 지금까지는 메타버스의 트렌드와 KT 사례에 대해 살펴보았고 미래 전략 변화 방향에 대해 제언드리고자 합니다. KT는 AI 빅데이터 클라우드 역량을 기반으로 디지코 기업 비전을 선포하였습니다. 디지코는 고객의 삶을 편리하게 해주고 다른 산업의 혁신을 이끌겠다는 지향점을 가지고 있습니다. 메타버스 디지털 기술도 단순히 기술 그 자체가 아닌 따뜻한 온도를 가져야 한다고 생각합니다. 앞서 보셨던 P4G 홀로그램 텔레버전에서도 코로나 상황을 극복하고 미래 세대인 청년들의 목소리를 원격 환경에서도 생생하게 전달하였습니다. 또 지난해에 이어 올해도 코로나로 마음껏 운동장에서 뛰어놀 수 없는 아이들을 위해 MR 스포츠인 KT 리얼큐브로 비대면 운동회를 열기도 했습니다. 이러한 사례는 앞으로 KT의 메타버스 비즈니스가 고객에게 새로운 경험을 제공하는 데 그치지 않고 기술이 현실의 문제를 해결하고 기술을 이용하는 데 있어 차별과 소외됨 없이 평등하게 기술을 즐길 수 있는 사회를 만들어가자는 지향점을 잘 보여주고 있습니다. 네트워크로 연결하여 진행한 비대면 운동회 동영상을 잠시 보시겠습니다. 메타버스 시대에는 인간, 공간, 시간에 대해 기존에 가지고 있던 상식을 벗어나 고객 경험을 다시 보아야 합니다. 이제 현실의 가상의 가상 공간의 활동, 과거 인물의 소환 등 새로운 인간의 모습과 활동을 볼 수 있습니다. 시공간을 초월한 새로운 하이퍼 익스피리언스가 가능해집니다. 이런 고객 경험의 변화로 기업은 마케팅, 광고 등 기존에 진행하던 비즈니스 전반에서 큰 변화가 일어날 것으로 보고 있습니다. 이러한 메타버스 변화 대응을 위해 디지털 트랜스포메이션을 제안드리고 싶습니다. 고객의 변화가 결국 기업의 변화를 만들고 이는 시장의 변화를 만들고 있습니다. 이러한 변화로 기회와 위기가 상존하는 메타버스 빅뱅의 시대가 왔습니다. 디지털 트랜스포메이션의 정의는 디지털 기술 도입이 아니라 디지털 기반의 새로운 비즈니스 모델을 창출하는 것입니다. 기술을 활용하여 고객의 가치와 경험을 혁신하는 메타버스 트랜스포메이션으로 미래를 준비하여야 하겠습니다. 지금의 메타버스는 생태계 개화기 수준이며 패러다임 전환기입니다. 이런 시점에 내부와 외부 경계를 초월한 개방적 협력을 통해 메타버스 생태계를 조성해야 합니다. 메타버스 생태계 조성은 KT 단독으로 할 수 있는 일이 아니며 관련 업계 중소기업과 상생도 중요한 가치 중의 하나입니다. 이를 위해 메타버스 원팀을 결성하기도 했습니다. 파트너사들은 시장과 고객의 니즈를 보다 더 면밀히 파악할 수 있을 것이며 사업 경쟁력 강화를 통해 사업이 번창할 수 있을 것입니다. 지금까지 KT가 중소개발사, 스타트업 등 우수 파트너사들을 발굴하고 육성해 오면서 사업을 확대시켜 왔듯이 앞으로도 다양한 협력사와 협력해 나가겠습니다. 이상으로 제가 준비한 강의를 마치겠습니다. 지금까지 경청해 주셔서 감사합니다.
That was indeed a captivating presentation. I'd like to ask a question. I heard that KT promotes a special warm metaverse differentiated from other companies. What is the difference from other metaverse?
KT proclaimed Digico company, and Digico is make life better for customer and lead innovation in other industries. Metaverse digital technology should have warmth for people and society rather than exist just as technology itself. KT supported the global use event by hologram telepresence technology because it was difficult to getting along at same place in COVID-19 situation. This was possible because of the warm side of the Metaverse technology. Also, KT hosted the on-tech Real Cube Sports Day event for children who lost their time at playground because of the pandemic. These cases show that KT Metaverse business is not only for providing brand new experience to customers, but also for making warm society through XR tech, which is overcoming present restriction and tech discrimination.
Thanks for your answer. I'd like to ask a second question. What fields will have the greatest impact when there's convergence with Metaverse technology in the future? And why do you think so?
Metaverse is not a new concept which came out of all of a sudden. You can understand that it's not typical from AR, VR, XR, business and expansion of the service. However, it is connected with the on-tech trend and it generates various customer experience that is unexpected way about space, human, and time. Existing XR technology was part of immersive media business. In the future, it will be applied in various fields as a general technology. Therefore, I expect Metaverse use case will be expanded from gaming and entertainment industry to all kinds of industry like tourism, education, and financial. Thank you.
Thank you very much for your answer. Next, we have Mr. Jinha Lee, Chief Product Officer of Spatial, an American augmented reality solutions startup. CPO Jinha Lee founded Spatial in 2010 with CEO Anand Agarwala, who sold BumpTop, a 3D software, to Google. Spatial is a company that provides a digital work environment that enables meetings in a virtual environment through avatars. It received an investment of 2.5 billion won from Uber co-founder Garrett Camp and others in 2017. Currently, more than 100 of the Fortune 1000 companies are considering pilot operations of spatial solutions. Then, we invite Jinha Lee, CPO of Spatial, to hear his insight into the development and future of immersive technology.
Hi everyone, my name is Jinha Lee. I am co-founder and chief product officer of Spatial. It's an honor to be here and share our journey with all the people listening in from all over the world. And thank you, President Lee, for making this amazing event happen.
Thank you for your wonderful presentation. If I could, I'd like to ask a question. I would appreciate it if you could tell me what advantages and disadvantages there are compared to the existing face-to-face communication or collaboration through a digital environment, and what kind of technical effort will be required to overcome the shortcomings.
Yeah, that's a great question. So there are a lot of pros and cons for face-to-face collaboration and this kind of 3D immersive avatar-based communication. So, I mean, video calls obviously allows you to see your real face and real facial expression, and that's great. But it's also like it's great for like one-to-one meeting, maybe like 1 to 3 meetings, but not so great for like 1 to many or like there are like more than 5, 6, 7 people. It's really hard to see like who is engaged and who's talking. And it's not as democratic like when you're like all just stuck in this like grid kind of layout versus 3D kind of avatar-ish, the realistic avatar-based collaboration. It really feels like you're sitting next to each other especially when it's experienced in immersive VR headset or AR headset, that you get this feeling of being together and being connected. It's just like your sound is kind of traveling from all different directions as if they're actually surrounding your table. And it's just the fact that they're 3D and right there, it gives you some kind of different level of connection. But also, I think the technology to make the avatars like more and more realistic is actually evolving really fast. And I think eventually we're gonna use more data coming from the headset, whether it be camera or sensors, that can be fed into the avatar in real time and animate your real-time facial expression. We have some prototype technologies to do that. But I think more fundamentally, what's more fundamental is I think it's people's right to determine like how they are represented. I think eventually, if you can allow customize how you represented the avatars, how much real you want to be, and how much expressive your avatar want to be, like what clothes you want to wear, like so those power to decide like how much of your representation is real and expressive. I think it's essentially a good thing for the communication.
Thank you for your answer. We welcome Dr. Frank Steinecke as our next speaker. Dr. Steinecke is a professor for human-computer interaction at the Department of Informatics at the University of Hamburg. He regularly serves as panelist and speaker at major events in the area of virtual reality and human-computer interaction. He is on the International Program Committee of various international conferences in the area of virtual augmented and mixed reality, as well as human-computer interaction, and currently associate editor of Frontiers in Virtual Reality. Dr. Frank Steinecke talks about how the fusion of mixed reality and artificial intelligence will change human-computer interaction. Dr. Frank Steinecke, the floor is yours.
Thanks to President Kwang Yung Lee and the organizers for inviting me to the KAIST GSI Global Forum. I really feel honored to talk about blended realities today. And such blended realities are nothing special. Even our own reality has evolved into a blended space, which is composed of the dichotomy of natural and artificial objects. And according to the German philosopher Bimbacher, the distinction between natural and artificial occurs at the impact level. So according to this definition, natural denotes everything that became without human being, and artificial was made by human impact. And although this distinction is central to our orientation in the world, artificial flowers or also genetically modified food show already the blurring between the natural and the artificial. And also our own field, computer science, has evolved into a blended space. In classical computing, data is encoded in so-called fundamental units called bits, where each bit represents a distinctive state, which is either 1 or 0. However, we already observe a shift from this classical model of computing towards other approaches, such as quantum computing. Here, data is encoded in quantum bits, so-called qubits, which can represent a 1, a 0, or a coherent superposition of both states simultaneously. And with this probabilistic approach of qubits, the area of 1 and 0 can be considered as a continuum, so as a blended space. And in my keynote, I would like to focus on 3 different fields in the area of artificial intelligence, mixed reality, and robotics, and show how we can blend them together. So let's start with artificial intelligence. Artificial intelligence is defined as human intelligence simulated by machines. And this is a very important distinction. So it clearly says that the machine itself is not intelligent, it just simulates human intelligence. And one very dominant or famous example of such intelligence can be implemented, for example, in autonomous systems or robotics. And here the Internet of Robotic Things enables robots or a combination of intelligent devices to monitor events, but also fuse sensors from a variety of different sources, use local and distributed intelligence, and allow robots to take real actions in the physical world. And here's one very dominant examples from autonomous cars. So here you see an example of Tesla, which, for example, fuses numerous sensory data from sensors such as GPS or the camera, time of flight sensors, accelerometers or gyroscopes, and fuse all this data in order to allow an artificial intelligence or a robot, an autonomous system, in this case a car, to actually steer around different environments. The next topic I would like to discuss is so-called mixed reality technology, which is a combination of real and artificial environments which are represented typically by some sort of immersive technology. And here's one video which shows the potential of this technology. So here you see a marketing video of Microsoft Mesh, in which the users wear some HoloLens devices, and now they are able to explore virtual environments or virtual objects in some co-located space. And this has, of course, enormous potential for education scenarios in which you can have your teacher right next to you or a trainer educating you in some aspect, for example, of engineering or other aspects. And if we think about how we can blend this together, artificial intelligence and mixed reality technology, you will quickly come up with something called intelligent virtual agents. And those agents are autonomous, typically anthropomorphic, that means humanoid characters in a virtual environment that again only simulate intelligence. And with such intelligent virtual agents, you can have more natural and multimodal ways of interacting. And here I would like to show you one video of my postdoc, which is interacting with such a virtual agent by means of voice and gestures.
Hello. Hello, how can I help you? Tell me about HoloBalance. In the HoloBalance project, we utilize holograms for personalized virtual coaching of elderly people with balance disorders. I can show you some project videos if you like. Are you interested in one of them?
The second one looks interesting.
Okay,
So,
here we go.
as you can see in this video, my postdoc is able to communicate with this agent in a very natural way by using, for example, voice and gestures. And now I would like to show how we bring this together, intelligent virtual agents, mixed reality, and the Internet of Robotic Things. And here are some examples from my lab. For example, my former postdoc is interacting using again a Microsoft HoloLens augmented reality display to interact with a shadow robot hand. And as you can see, he's using voice, gestures to interact with this robot in order to control this robot, which is then, for example, able to grab some boxes and move them around in space. Another example comes from the area of using embodied avatars for showing robotic things. So in this case, the idea is that you have some robot, maybe an autonomous car or a vacuum in your apartment, and you give them, by using mixed reality technology, some anthropomorphic appearance. So you embody them in some humanoid representation, as illustrated in this video. And by doing so, it gets easier to interact with the robot machines or identify their intentions. For example, how can a car tell you that it wants to turn left or right? And herefore you can use some augmented reality technologies as seen in this video. And finally, I would like to show you one video in which we use an intelligent virtual agent who is able to interact with the real environment around him, again by using some sort of robotic things.
The first interaction is based on a robotic golf ball. Through a weight shift inside the outer shell, the ball can move with 3 degrees of freedom with a maximum speed of 1 meter per second. We designed a user study within a cave that simulated a mini golf match between the participant and a blended agent. The animations of the blended agent were synchronized with the movements of the robotic ball, resulting in the illusion of the agent hitting the ball. The agent played the ball along a predefined path into the hole. Afterwards, the agent headed back to a table at the entrance of the mini-golf course to record her score using a prepared scorecard. In this context, we demonstrated our second virtual physical interaction, persistent writing on a sheet of paper using a thermal table. The table is a custom-built device to activate thermochromic ink on a sheet of paper via temperature variation. Initially, the blended agent writes a projected score onto the sheet of paper. In the course of the mini-golf match, the temperature is switched from high to low, and the previously transparent ink turns black. Therefore, when the user takes the scorecard outside of the mixed reality environment, the score is still visible as it is physically written. Participants of the study described the experience as fascinating, more realistic, and memorable. Further information can be found in the paper.
So coming towards the end of my talk, I would like to give a short overview of what I think how those blended realities will evolve in the future. And one of the good things in computer science is that we know that everything evolves exponentially in our field. And based on this exponential advancement, we can extrapolate what will happen in the future. So let's have a look maybe towards the next 15 years. How will this technology evolve within the next 15 years? And as I said, already since 100 years or so in our field, we live with exponential advancement. Most dominantly known from Moore's law, which states that approximately every 1.5 years, our technology will double in performance. So that means every 18 months we will have machines which will be double as good as the ones that we have today with respect, for example, to bandwidth, storage, processing power, GPU power, resolution, etc. And if we have machines which will be double as good in 1.5 years, we know that they will be 4 times better in 3 years or 8 times better in 4.5 years and so on. And so we can easily make the calculation how good these machines will be in 15 years from now. And if you do so, you will realize that the machines that we will have in 15 years will be 1,000 times better than the machines that we have today. And think about this, what this means if our machines will be 1,000 times better. That means that we will be able to solve certain problems that we can't solve today with our machines that we have today. And one of those examples is the so-called graphics Turing test, which is a small twist from the actual Turing test in the area of artificial intelligence. Here the idea is that you are able to display a computer-generated environment in such a way that you can't distinguish reliably if this is a computer-generated environment or if this is a real environment. And it has been calculated that you need approximately 0.5 to 1 petaflop of sustained GPU performance in order to solve this issue. Since we are today somehow in the area of 6 teraflops or so, that means being 1,000 times better, we will certainly solve this problem. And approximately in 5 to 10 years, we will be able to render interactive computer games, for example, which we can't distinguish from the real world anymore. And let's have a look what this means, being 1,000 times better, for example, in computer graphics displays. So when I finished high school, I played some computer games, and one of the best games back in 1996 was Tomb Raider, and Lara Croft was looking like this in that computer game. So that was the best rendering that we could get in an ordinary graphics computer game. However, 15 years approximately later, Lara Croft was already looking like this. And 3 additional years later, she was already looking like this. So you have seen that being 1,000 times better in rendering makes a significant change to how we perceive the computer-generated environment. And it also gets clear that if we get 1,000 times better in rendering, for example, compared to today, we will not be able to distinguish computer graphic content from real content anymore. And of course, this has a lot of challenges when it comes to moral ethics and also the impact on our society. We will also observe that the form factors of, for example, mixed reality technologies will further shrink. And this also applies to the other technologies, such as robotic things that we discussed in my talk earlier. And we already observed that all big players in the game filled in their patents regarding such contact lenses, which are not only able to display computer-generated environment towards your eyes, but which are also able to measure the environment around you. And with this new technology, this innovative display technology, we will also observe a shift or a paradigm change how we interact with computers. So we will observe that those smart glasses at some point will replace the smartphone that we have nowadays and which are basically the dominant way of how humans interact with computers today. And we already observe these shifts. So for the first time in the last 2 decades or so, we see a decrease of the global smartphone shipments from 2007 to 2020. And in particular in the last years, we see this decrease. And that's the first time ever in global smartphone shipments that we see actually a decrease of the global shipments of smartphones. So hence I believe that virtual reality and artificial intelligence have enormous potential to enable more natural and more human-like communication. And this will revolutionize, for example, the way how we work, but also the way how we learn, the area of education. And it will also change how we interact with computers or how we use computers for computer-mediated communication and interaction between humans over distance. So as we are forced nowadays due to the corona pandemic. Artificial intelligence and also mixed reality have enormous potential to take over a lot of tasks from us, ranging from autonomous driving or decision making, and also in the area of using robotics to perform certain tasks. But at the same time, those technologies give us the time and also the freedom to focus on the essential aspects of human beings, since empathy, emotions, and creativity can only be simulated by machines. And I'm really looking forward to work in this field and blend together reality and virtuality, but also human intelligence with virtual intelligence in order to make our world a better place. So thank you very much for your attention.
Thank you for your insightful presentation. I'd like to ask a question. If the combination of AI and convergence reality is maximized, what kind of technology can be realized in the future?
That's a very good question, and I think we will see in particular a further miniaturization in the different technologies. So, for example, we will see smart glasses, which will have the size of a contact lens at some point. We will also see robotic and wearable devices, which we can wear either as implants in our body or maybe on our body, like, for example, smart watches, which will then help us, for example, to induce also novel ways of interacting with computers. And at some point, we might even see simple brain-computer interfaces, which will be able to allow to use our thoughts as input to interact with the computer. And with such a blended space of being able to use my thoughts, using gestures, use my eyes to interact with the reality as well as the virtuality, I think this will bring us really interesting future opportunities and will really revolutionize the way how humans interact with each other, but also with machines and artificial systems.
Thank you for your answer. I'd like to ask another question. Should immersive technology aim to create a virtual world that is so realistic that the difference between the real and the virtual world cannot be recognized? What do you think is the best way to utilize realistic technology?
I think it's a good question if the ultimate goal of virtual reality is to display objects that look as realistic as possible so that we can't distinguish them anymore. I don't think that this is the major goal. And as I said in my presentation, I think there are also a lot of ethical and societal and also legal questions when it comes to display objects that we can't distinguish from the real world anymore. I think the actual potential is much more in the field of showing something which goes beyond what we could actually display in reality. So, for example, in the area of education, you can display complex mathematical and dimensional functions in this the real world and virtual space. You can show, for example, experiments of natural science with high complicated quantum technologies in such a mixed reality space, and thereby display these complex things for multiple people in a shared space in a much more multimodal, intuitive, and natural way. And I think this is the actual potential of this technology.
Thanks very much for your answer. Here's a special time to showcase some brilliant immersive technology in today's forum. We invite Mr. Marco Tempest to experience a new virtual reality. He is a Director's Fellow at the MIT Media Lab and a creative consultant at the NASA Jet Propulsion Laboratory. He's the Executive Director of the NYC Magic Lab, a science consortium exploring illusion and digital technology. Applications include media marketing, entertainment, and the prototyping of future technologies via immersive experiences. His presentation today will be on inventing the impossible. So, shall we go on a journey to a new world? Welcome, Mr. Marco Tempest.
Hello, everyone. I'm delighted to be here with you today, presenting at the 4th International Forum of the KAIST Global Strategy Institute. I want to say a big thank you to President Di Kwang Yang for inviting me to present today. So without further ado, let's get started. As you already heard, my name is Marco Tempest. I'm the founder of the Magic Lab in New York City and the creative consultant and technologist at NASA's Jet Propulsion Laboratory. I help organizations bring their technological stories to life. I work with augmented and virtual reality, gestural sensing, robotics, AI, and a whole host of other interesting technologies to create experiences that are clear, memorable, and seemingly impossible. Impossible because I'm also a magician, a techno-magician. Now, I am interested in using illusion and technology to create magical experiences. And I'd like to share a few thoughts about magic, illusion, and the situation we currently find ourselves. We are here separated, perhaps by hundreds of thousands of miles. And yet here we are, drawn together by technology, exchanging ideas that might one day bring us closer. Magicians, and by that I mean entertainers who specialize in theatrical illusion, have always had a deep interest in technology. In fact, they are early adopters, secret adopters. They use new technologies in their performances before they become known to the general public. Now, we can draw a line through the history of magic and see how it takes advantage of each emerging technology, covertly employing it to create inexplicable effects. These include the use of pneumatics and hydraulics by the magicians of ancient Greece, chemistry by the 16th century magicians posing as alchemists, electromagnetism used by the 19th century French magician Jean-Eugène Robert Houdin, optics to create ghosts on the Victorian stage, cinema pioneered by magician Georges Méliès, wireless as a means of secretly transmitting information by vaudevillian mind readers. As will be known to many of you, Arthur C. Clarke said that any sufficiently advanced technology is indistinguishable from magic. There is some truth to that, but magicians don't just depend on technology to create their illusions. They make great use of psychology. And although technology changes from year to year, human behavior remains largely the same. People react to magic today pretty much as they reacted to it in the 16th century. And over those centuries, magicians have performed their tricks millions of times. It's the world's largest field test of human behavior when confronted with the unexpected. Psychology is important because illusions don't happen in the hands or on the stage. They happen in the mind. Your expectations guide your response. Now, I've spent several minutes talking about technology and illusion. I've listed a host of methods used by magicians: chemistry, hydraulics, pneumatics, optics, and I've set your mind down a path. And without realizing it, you have been primed for what you're about to see next. A floating orb of light. It's not a special effect. It is really happening. If you were here in the studio, you would see exactly what you're seeing on the screen right now. But how do you perceive this effect? In the 16th century, it might have been judged witchcraft. But here we are at a technology conference. Maybe here it seems more like the embodiment of Clarke's dictum, an advanced technology posing as magic. Now, how we frame something changes how it is perceived. That doesn't only apply to magic, it can apply to almost anything. It can apply to our online experiences. What do we want them to be? How can we improve them? For magic to work, we have to gain, retain, and manipulate attention. The current situation where the magician and the audience cannot share the same space has created many challenges. How do we keep the attention of people who may be thousands of miles away? Audiences want to listen, talk, and have new and surprising experiences. but we need to give them the right arena in which we can maintain their attention. It's a challenge everyone has. How do you keep someone from falling asleep while they're watching your Zoom presentation? To that end, as you've already seen, I've been doing some experiments. Everything in my presentation today is driven by technology and 100% real time. It's a test to see if we can make the virtual space we now inhabit as engaging as the real spaces we hope to return to. So let me lift the curtain here. I'm broadcasting from a tiny studio in my basement here in Zurich, Switzerland. A green screen, a handful of lights, and some readily available tech enables anyone to set up a virtual studio. Now, the goal is to take technology and add that touch of magic and psychology to capture the attention of our online audience. Provide a new kind of online experience and make our presentations more immersive. All of this is controlled with a simple clicker. So let me give you a demonstration on how this technology can be used to enliven our online experience. I mentioned Arthur C. Clarke earlier, who said that any sufficiently advanced technology is indistinguishable from magic. But it is also true that any sufficiently advanced magic is indistinguishable from technology. These drones, for example. A 100 years ago, that would have been the magic of levitation. Jump. You recognize it as technology. So where is the illusion? As I said earlier, the magic happens in the mind. And with suitable framing, it's possible to convey the idea that these machines have personality. They react to everything I do. Advanced algorithms allow these autonomous machines to fly in close formation, aware of each other, aware of me. Mathematics that can be mistaken for intelligence, and intelligence for personality. A machine that appears to be alive. Does such a thing exist? Anthropomorphism, that's the illusion. Technology plus magic gives us a glimpse into the future. So I'm almost at the end of my presentation. I do have a few closing remarks, and then I think we're going to have a few questions from the Institute. The current situation is a challenge for us all. The novelty of the online conference did not take long to disappear. How do we create an engaging shared experience where we cannot share the same space? Now, working in our favor is that audiences want to listen, learn, share, and participate. As Samuel Coleridge Taylor said, audiences willingly suspend their disbelief. Audiences give us their attention, but we need to do more to retain it. Having gotten their attention, we need to take them to exciting places, surprise them. We can do this by thinking a little more creatively about how presentations can engage people beyond the screen. New technologies are always welcome, but they are not vital. The experience is not in the technology. It is in the mind of the audience. And we can draw on the work of those who specialize in the psychology of engagement. So let's rethink and reframe our presentations. And instead of delivering information, we can share stories that stimulate the mind and our senses. Stories that steer our emotions and truly engage. If we can do that, we can create online experiences that go beyond the technology we are using. Some call that magic. Thank you very much for watching my presentation. Again, a big thank you to President Lee Kuan-yeong for inviting me. And I think we have a little bit of time for a few questions right now.
Thank you for your insightful and gorgeous presentation. I'd like to ask a question. Can you please tell us a little more about the technology you are using in this presentation?
So the technology I use, I presented before. I'm in front of this green screen environment. I think it's the perfect way to use like an early version of the metaverse to engage people a little more intensely in our presentations as we are stuck at home. And broadcasting this through video is a very frictionless experience for our audiences.
My next question is, how did you start merging immersive technologies such as AR and VR with magic content?
I think augmented and virtual reality are a natural fit for magic. They are intrinsically magical technologies, especially now that not many people have experienced this in high fidelity. So to add that extra layer to make our stories or my magic, the narratives within my magic more memorable is a perfect match. And so I think one thing we need to do as inventors or practitioners in this field is we have to evolve with the technology as it evolves. And we can never just go for the most obvious use cases, the usual suspects, right? These technologies are just have such an incredible potential, and there's so many other things you can do with these technologies. And I think this is kind of the mindset of the magician, figuring out what else we can do with a new technology as it emerges and while it's still magical to our audiences.
Thank you. One final question for you. What emerging technology topics are you most excited about?
Yeah, so something I'm really excited about is machine learning, and also how some of the machine learning hardware makes it into the devices on the edge or the devices we're actually wearing. How magical is it to have a device which can reason about the user's perception? So we can have gaze tracking, we have IMUs to see if somebody is moving slow or fast, is reactive to the content. The gaze tracking enables us to see if something was overlooked or not seen, if somebody got distracted. So there's a certain budget of attention we have from any user interacting with our technology or with our stories. And to gain insights on these interactions and then understanding it, then incorporating that into our user experience, I think this is a really magical field with lots of new opportunities. Be that in entertainment, storytelling, or in learning, immersive learning and training. Well, thank you very much again for having me. A big thank you to President Lee Kuan-yeong for inviting me. And bye-bye, everybody. Thank you.
Thank you very much for your answer. Now we will conclude our plenary session. I'd like to thank all the speakers for their excellent presentations and the audience for watching this online forum. I'm Professor Scott Gabriel Knowles at KAIST. It was my pleasure to moderate the first half of our forum today. Next, we will continue with our keynote session and panel discussions. Please stay tuned.
Hello everyone, I'm Professor Andrea Bianchi from the Department of Industrial Design at KAIST. It's a great honor to host the fourth Global Strategy Institute keynote session today. In this keynote session, we will focus on education and talk about how metaverse and immersive technologies are currently used and can support education with large audiences. As I also conduct research in the field of virtual reality and learning technologies, I'm very excited to join today's forum. The first speaker of the keynote session will be Bom-Ju Kim, Head of Evangelism at Unity Korea. He has experience in planning various content such as animation, movies, and game productions, and is currently researching the process of creating new media content using game engines at Unity Korea. Bonju Kim was awarded at the KINSES 2016 Education Awards for developing educational content using game elements. Taking advantage of his experiences, he talks today about the possibilities of education in the metaverse. Mr. Bonju Kim, the floor is all yours.
Hi, I am very honored to announce the keynote at this important event today. Also, I am very grateful to President Lee Kwang-hyung for inviting me. This topic is about what role metaverse technology can play in future education. As you all know, the concept of metaverse has been growing rapidly in recent years. And I still have no way of knowing what the future that the technology can create and where it will end. However, based on the cases and experiences I have seen in the field, I can only get hints about what will change if metaverse technology is used in education. So today, I would like to give you an insight by showing various examples of a concept that I think are important in the metaverse and examples of their use, including projects that I participated in. There are various definitions of metaverse, but I will summarize it into two elements: virtual space and virtual economy. I think the metaverse is a technology that helps discover new values and make human intelligence better when these elements are properly combined. Among them, virtual space is a critical concept provided by metaverse. Of course, we have been using virtual space in media such as AR, VR, and video games before. But it wasn't easy to imagine that the internet itself could be expressed and utilized as a virtual space until the concept of metaverse. However, now, ordinary citizens also have expectations that the internet can be expressed as a virtual space and avatars that people can experience. And this is a great opportunity for internet's future. The virtual space that resembles the real world shakes the dichotomy that the physical world is real and the virtual world is fake. Generation MZ spends more money on virtual bags than on real ones. Through this phenomenon, we have been able to think about the real important value hidden in the dichotomy between the real and the virtual. When thinking about how this metaverse can affect education, the first thing that comes to mind is Edgar Gale's Carnot experience. Edgar Gale has argued that the direct experience with a sense of a purpose is more effective than conveying abstract concepts through text. Confucius in China also said that we forget what we hear, remember what we see, and understand what we do. Metaverse goes beyond the internet of text, pictures, and videos, and is developing into virtual space and a social community based on it. I think the changes that this metaverse can give to education will vary. I would like to introduce some of them. I think the purposeful experience emphasized by Edgar Gale is an essential part of the various strengths that the metaverse can give. Learners who understand their role based on the environment around them, rather than simply receiving abstract concepts, will try to solve problems by mobilizing their abilities and imagination. And in the process, many learning effects appear. And for these changes, it is necessary to give the learners confidence. Metaverse is an optimal technology to provide such a desperate space. In addition, self-analysis through learner data, personalization of learning speed and direction, and intuitive feedback can be some of the characteristics of metaverse learning. So let's see how these elements can be implemented through the example of one educational MMORPG. Developed by NCSoft and serviced by Hodu Labs, Hodu English was a project that gave a lot of insight into imagining the possibilities of learning in a virtual space using a game system and its benefits. I have been involved in this project for about 7 years as a game designer, so I will introduce elements that help you imagine the metaverse and the potential of education in it. First, I'll show you a short video introducing what kind of game it is.
매일 떠나는 영어 여행. 영어로 통하는 세상, 호두 잉글리시를 소개합니다.
Hello. Hi, I'm Amy. You're the new linker. Yes, I am.
캐릭터와 영어로 대화하며 친구가 될 수 있어요.
Hello, kid. Nice to meet you.
Nice to meet you too, sir.
You're new here.
Yes, my name is Ellie.
Oh, I'm Bruce. I'm a police officer.
I see. Can you spell your name?
300여 명의 영어 친구들과 다양한 대화를 나눠보세요. 매일 전개되는 흥미로운 스토리. 곳곳에 숨겨진 흥미로운 영어 퀴즈. 영어 공부가 놀이보다 재밌어집니다. 대화를 통해 향상된 영어 말하기 실력도. 자연스럽게 습득한 다양한 어휘도. 배틀로 마스터한 영어 표현도. 개인별 학습 관리 시스템이 체계적으로 관리해드립니다. 즐거운 영어, 호두 잉글리시.
As you can see in the video, Hodu English revolves around the gameplay in an MMORPG environment where quests are conducted through dialogue and persuasion instead of combat. Here, the player's role begins with empathizing with his or her role in the worldview. After understanding their role as a hero to save the world, the learners could immerse themselves in that worldview and autonomously continue their learning activities to fulfill their role. If the perfection of this worldview can convince the players will continue with justification for his or her learning behavior. In addition, the report that can statistically view the educational results of these autonomously conducted activities is also sent to parents, helping them understand the learners' actions and encourage them. It is not easy to achieve the personalized difficulty level in real-world education, but it is possible in Metaverse based on the real-time engine. The speech recognition engine that determines the success of a speech automatically adjusts the threshold according to the learner's pronunciation level, helping the learners to maintain a flow that is neither too easy nor too difficult. Learners and parents have well received this English educational game called Hodu English based on these elements. Personally, the most memorable scene was the story of a parent who said that a child who hated studying English wanted to go to an English academy to learn Hodu English. These examples have led me to believe that properly used technology can play a major role in motivating learning and giving children equal opportunities. There are many other examples of using Unity's Metaverse technology. These are examples of improving learning or training effect by delivering vivid experiences that the Metaverse space could only convey. Some of them are winners of the Unity for Humanity Challenge. History Maker is one of the VR education projects selected by Unity for Humanity Challenge. Students can easily empathize with their roles by playing famous historical characters. There is no more vital way of empathy and understanding than putting yourself in someone else's place.
77 years ago, our fathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal.
Welcome to today's Social Studies classroom, where the virtual reality content creation tool, History Maker VR, can enhance the learning experience. Students can immerse themselves in history while showing off their knowledge by embodying 8 diverse characters across U.S. history, from Ben Franklin to Sonia Sotomayor. It's easy to use. Students set up the scene and select their props, create their performance, import their script, and start recording. Export, edit, and share their performances with teachers and classmates. For educators, History Maker VR comes with a desktop complement for classroom setup, management, and student assistance. Seamlessly integrate History Maker VR into your curriculum with sample lesson plans and activities to help students easily begin creating their own personalized VR experience. Both students and educators were involved in the development of this standards-aligned experience, making it both intuitive and motivating. Create excitement, increase retention, and engage your students with this tech-forward tool. History Maker VR. Embody history.
Breaking boundaries immerses players in the life and the times of famous figures like Jane Goodall, Marie Curie, and Grace Hopper. Players will explore each scientist's real-life work environment and will gain the intimate knowledge of their lives and achievements in a historical context.
Today, radioactivity is used in a wide range of applications. In 1898, though, it was still considered a mysterious property and hard to study. This all changed with my work to discover radium, a highly radioactive element. Before computers could fit in your pocket, they took up an entire room and weighed 5 tons. The United States Navy was one of the few groups with the ability to maintain such a device. And when I joined the Bureau of Ordnance Computation Project, I started on the path that would lead me to making computers something everybody could use.
When I first got to Gombe in 1960, I had no model to follow. There was nobody out there studying chimpanzees. So I simply conducted the study as I had conducted studies on my own, on the animals around my childhood home in Bournemouth. I spent every day out in the forest with the chimpanzees if I could. So those were, I think, the best days of my life.
Korea Electronics and Telecommunications Research Institute has developed VR firefighting training system. Firefighters can experience and train their skills with this. You can get more immersive and practical training by using your own body in the presented situation in VR. The Real Studio, a Korean VR content developer, has created a VR education program that allows you to experience earthquake situations physically. Learners can experience such a disaster environment in VR, learn how dangerous these situations are, and respond correctly through actual activities. Let's talk about Unity, a technology for implementing the metaverse. In addition to the project introduced today, many real-time 3D projects and Metaverse projects worldwide are being created by Unity. Perhaps one of the reasons is that it is an engine that supports most devices and platforms around the world. We, Unity Technologies Korea, are continuing to work hard to support Metaverse project with the direction of universality, accessibility, and extendability to help these developers. This concludes my presentation. Thank you.
Thank you for your wonderful speech. Next, we would like to introduce Professor Woon Tak Oo from KAIST, an authority in the field of augmented reality. He's currently serving as the Dean of the Graduate School of Culture Technology at KAIST. He's also the Director of KAIST Culture and Technology Research Center and Augmented Reality Research Center. In 2001, he coined the term ubiquitous virtual reality, and his main research is to implement ubiquitous virtual reality in smart spaces to realize augmented humans, augmented cities, and also augmented societies. Professor Wu gives a speech titled Digital Twin, Metaverse, and XR toward self-motivated learning platform.
Good morning, good afternoon, and good evening. First of all, I'd like to thank GSI International Forum team for inviting me here. It is my pleasure to have a chance to share my experience and thought on the future education, especially education exploiting Metaverse. I will explain basic concept of Metaverse and then present on the possibility of reality virtuality convergence platform in terms of a digital twin, Metaverse, and extended reality. Today, I will talk about forest rather than trees, a key concept rather than a detailed individual technology, and then talk about possible future direction of Metaverse-based education. Some is already curious whether the Metaverse is bubble or not. Some ask me whether winter of Metaverse comes again. How can it make the Metaverse sustainable? How can it make it beneficial in education? The core message of my talk is the Metaverse goes beyond just a fun place. So the scope of content in Metaverse needed to be expanded to the 3D virtual object, to information, knowledge, and experience. It's a reality virtuality convergence platform. At the same time, it is social media and economic platform that anyone can easily access and utilize it in their daily lives as well as education. I have been doing research on ubiquitous VR for the past 20 years. Since then, I worked on the realizing Ubicom concept. The basic concept of Ubicom is linking between reality and virtuality and then augmenting data in the real physical space. The purpose of the augmentation of the data in the real physical space is to support interaction and collaboration between online and offline, between human and human. What is the metaverse? It has similar concept. We are living in physical space. We can make the corresponding virtual space. The virtualized reality can be connected through the context of interest. Then we can utilize it in real physical space. In this concept, I worked on the ubiquitous VR when I coined in year 2001. For the first 10 years, I tried to combine the concept of ubiquitous computing and augmented reality. The basic concept is collecting signal from the physical space and then analyze, then feed it to the real physical space. Last 10 years, I tried to expand this concept to augment humans' ability in various senses. Human can be extended based on its body, its brain, and its social ability. For the next 10 years, I tried to combine to work together. I tried to use augmented reality to expand the city and the citizen and society. Recently, Metaverse is very famous because of this person, Jensen Huang. He claims Metaverse is coming. He claims, Metaverse is coming nowadays. However, the more accurate, the expression might be Metaverse is coming back. I will explain why this is true in Korea. Recently, Another person, Mark Zuckerberg, he said he want to make Facebook as Metaverse company in next few years. Done many interesting things to make the Metaverse ubiquitous. In addition, the president of KAIST recently he announced educational Metaverse is coming. We are experiencing educational disruption during the COVID-19. In order to provide a more active, immersive, and inclusive learning opportunity, Metaverse might be a good candidate. However, still we are not ready to explore the advantages of the Metaverse. How can we utilize the concept of Metaverse? In order to understand the concept of Metaverse, we have to go back to the history. This slide shows the trend of Google representing interest of the common people in this area. Google Trend shows the trend from year 2004 when Metaverse community start to discuss. As you can see, in early year 2000, we can see some noise looks like the peak, and then recently we can see another peak. That's why we call it Metaverse is coming. However, in Korea, as you can see, mid year 2000, many peak already occurs. Korea government spent a lot of money on that direction. And then, the trend, the interest on this terminology disappeared in Korea. Why? As you may guess, smartphone appeared. Many, the virtual or digital contents are consumed in the mobile platform instead of internet. This is another interesting plot showing related area. The orange color shows the interest on virtual reality. As you can see, the interest on virtual reality decreased since year 2000 and then comes back in mid-year 2010s. Why? Mark Zuckerberg invests big money in this area. What about last 1 year? As you can see, over the world, the interest shows on virtual reality, augmented reality, metaverse, and the digital twin. In Korea, the interest on 4 different areas pretty much similar. It shows that Korea has possibility on utilizing all related information and communication technology at the same time. That is the key how the Korea can drive the metaverse in education. Recently, there are several different opinions exist on the metaverse, especially the virtual reality community claims the second life is the origin of the metaverse. Recently, Infinite Office, supporting the office work without going to the company, is regarded as the representative example of metaverse. Game community claims that Roblox or Fortnite is an example of the metaverse. Some defines the metaverse as a virtual experience through the avatars. So digital human or Gepetto can be considered as metaverse. Some consider the digital asset. Digital asset is the important component of metaverse because we can purchase virtual content in metaverse. Another community claims Web 3.0 is the metaverse because Web 3D community try to access the digital information in the 3D space. Then what is the metaverse? How should we understand the metaverse? There are several different versions of metaverse exist. It looks like just a touching elephant by a blind person. How do we understand the elephant? That's the topic I want to introduce today. In order to understand the relationship between extended reality and metaverse, we need to understand reality-virtuality continuum. It is possible to merge both the reality and corresponding virtualized reality. Depending on the type of the merge, it is called augmented reality, augmented virtuality, Augmented reality emphasize reality, and augmented virtuality emphasize virtuality more. Diminished reality is to erase what we don't want to see in reality. And mediated reality is to allow us to explore new information or spaces by mediating object of interest. The same story can be applied to the virtualized reality. The vertical direction of mixed reality is the metaverse. That's how I define the metaverse, how I understand the metaverse. There are various layers can be created with the imagination. This space can be experienced and explored through the avatar. I define this whole world as ubiquitous VR or extended reality. Let's look at the clear definition of the metaverse. The word metaverse first appeared in novel Snow Crash in year 1992. At that time, the metaverse can be experienced with glasses. The spec of such glasses is pretty much similar, similar to the spec of the Oculus Quest 2 recently announced. In mid-years 2000, the open source community get together to define the metaverse. At first, they defined metaverse as a future internet. They defined metaverse as a shared and open standard-based virtual space. Since then, the community, ASF, defined the metaverse as the convergence of virtually enhanced physical reality and physically persistent virtual space. It has 4 key components such as live logging, a virtual world, mirror world, and augmented reality. These 4 components are pretty much important concept of understanding metaverse. This is component, not a type. Where does the metaverse start? Where it is now, and where does it go? The concept in novel, Snow Crash, was released in the internet virtual world in the year 2000. The Second Life is a good example. Recently, it is experienced in the mobile virtual world. The Roblox or Fortnite is an interesting example. Then what's next? There are various possibilities, but among them, the most likely candidate would be the wearable metaverse, which can be experienced and utilized in our daily life using the XR glasses. By the way, it is possible for the wearable metaverse to reopen the digital gold rush era. In order to pave the way to the digital gold rush era, the metaverse ecosystem must be well established in the advance so that the reality virtuality convergence space become both a social platform and thus an economic platform. To realize such a platform, it is necessary to build and utilize integrated infrastructure such as Internet of Things, 5G, digital twin, AI, metaverse, NFT, and extended reality. For the sustainable metaverse, the integrated platform must be open, reliable, and interoperable. At the same time, it is necessary for us to prepare for various social, economic, and legal issues. How can you use this metaverse ecosystem in our daily life? Our society is changing. Last year, we met people each other. Since the COVID-19 occurs, we cannot meet people. The meeting is limited to the online. In the future, even if the COVID-19 disappears, another COVID-like will appear. How can we educate? The society will be changed. The future of education also will be changed. We need new connections, new communications, new types of collaboration might be needed. In that sense, metaverse can be a good candidate. How can we use metaverse in our daily life? One good example might be augmented city. Using the available ICT, we can build virtual world, and then we can connect such virtual world to the real physical space. The purpose of the merging is to utilize, analyze the information, knowledge, and experience in metaverse to use in our daily life. Augmented city is a good candidate of utilizing metaverse. Augmented city is a smart city that improves our daily life by organized integrated ICT. By doing that one, for that purpose, we can combine reality and virtualized reality. We can augment information, knowledge, and experience in real physical space based on the location. Then we can achieve a bidirectional interaction between reality and virtuality, even reality and reality. over the place. It allows the citizen to participate to solve the problem in the city. How can we do that? Augmented citizen might be possible with available ICT technologies. Wearable glasses give opportunity for the person to access to the digital information given the location and the context. 5G will allow to collect signal from the physical space to the virtual. Edge or cloud will analyze such collected signal. AI will help to understand the context of the physical world. Even complicated problem can be solved by the cloud or supercomputer connected to the cloud. In this scenario, IoT will be embedded in the city, and then edge and cloud collect the signal and analyze. Digital twin visualize what's going on in the city. Even digital twin can be used to predict the future. The result can be fed to the real city life using the XR platforms. Using this one, we can plan, we can monitor, we can operate the city. Even in the viewpoint of a citizen, we can experience several different things. We can communicate, we can collaborate. Even we can expand ability of a citizen. Given that scenario, our life will be changed. Today's topic is learning, so I will talk about the learning. How can we use Metaverse? This is current version. We can build school, class in the Metaverse. We can put screen. We can show some PowerPoint slide there. Teacher can educate student. That is pretty much similar to the current version of the school or class. However, in the future, the education might be different. Even if the girl didn't go to the school, still she can access to the classes by wearing the glasses. She can meet her friends in her living room. They can teach each other. There is no teacher, there is no border, there is no grade. They just can learn what they want to learn. And then they can apply the knowledge to the real field. That might be the future of the education. So as I explained, we can use Metaverse in the future education. Students ask questions and find the answer on their own rather than directly taught by the teacher. Students define problems, accumulate knowledge, and use it appropriately. But still, there are several remaining challenges. Then what is the new role of education? What about the future education for creative convergence talent? What about the personalized learning? In case of the flipped learning in Metaverse, what is the role of the teacher? What is the education in case of the personalized learning? Traditional classroom, there is one teacher. There are several students. That is one-to-N education. What about one-to-one education? There are several issues. If we can use AI, how AI can be combined with this education. One person in host, the other person or the other students are located in different places. How can we combine two different locations together? There are several issues. How can we make physical environment similar? How can we make experience similar, the experience in the same room? They have different location. Maybe they are in the living room. One students are in the study rooms. One student might be in the classroom. Then how can we combine all together? In that scenario, avatar can be used to access to other place. How can we make avatar? How can we make avatar represent emotions? How can we make avatar-based collaboration? The minimizing asymmetry and maximizing social presence might be an interesting challenges. This concept can be applied to the several different meta-X. We can use this concept to the exhibition, performance, tourism, exercise. There are several different applications. If we apply the Metaverse in our daily life, we can expand humans' ability in various senses. We can expand, the body's ability. We can move around. We can unvisitable place. We can support brain activity. We can support the person to make a proper decision by providing, the information and knowledge just in time. Even the metaverse can help to improve social relationship with the friends, colleagues, the families. There are several, the advantages in using metaverse. So the metaverse transforms the way we live and interact with the outside world. It will revolutionize the industries in terms of the productivity, efficiency, and the safeties. However, there are several technical challenges. Video avatars, still unrealistic. Content authoring in metaverse is challenging problems. How can you make, the platform combining digital twin, AI, metaverse, and extended reality? Can we provide wearable platforms, hardware platforms, interface, interaction schemes? What about the network? In order to support metaverse in our daily life, high-speed network is pretty much key infrastructure. Wearable device is another issue. Also, the industry ecosystem is another challenge. We have to solve these issues in order to use metaverse. Metaverse is coming. Metaverse is coming again in Korea. How can we use metaverse in our education? We have to change the concept. We have to, we need to shift thinking about the metaverse. We need to consider the metaverse as a social overhead capital. There are several remaining homeworks. Metaverse is social good. Metaverse for social good. How can you make a sustainable? How can you make students smile? Given that, we may use metaverse in our future education. In general, new challenge will have mistakes, failures, and the setbacks. Even so, those who never give up and take on challenges change the world for the better. I hope that we can take on the challenge together to build a new metaverse with a reality virtuality convergence platform. I hope we can change the future education. Thank you.
Oh, wow, wonderful. Was a great presentation and I really learned a lot. That was very surprising. Now, to better understand where immersive technology is applied in education, we invited Mr. Joseph Ferraro, co-founder and executive chairman of Labster. Labster is a tech company that provides experimental services in virtual reality. Specifically, it allows performing dangerous and expensive science experiments via virtual reality. Labster conducted more than 120 experiments in various fields, and more than 5,000 experimental tools are available on the Labster platform. I would like to invite Mr. Joseph Ferraro for the presentation.
Hi, I wanted to speak to you today on behalf of Labster because I'm so excited about the growing metaverse and how it's changing the way we teach and the way that we learn. By now, we've all seen Facebook Workrooms, which Mark Zuckerberg unveiled in August, and it's really exciting to see mainstream media get so interested in this type of technology. But let's face it, it's still early days. Facebook Workrooms is way behind most popular VR apps and video games. In fact, it's really not so different from today's Zoom or Microsoft Teams experience. It just has a different skin. The most important feature of Facebook's Workrooms, right now anyway, is its dedication to business application. This is how Facebook is going to leverage its investment and the scale of its audience. But that's not the metaverse as it could be. It's not the metaverse that we want to create together. Without inspiring thought and participation, the classroom of Workrooms may just be a teacher lecturing in front of a room full of avatars while sitting at desks while they receive ads for products, in-world spending opportunities, and chat invitations from strangers or conspiracy theorists. I believe we must build a richer and more meaningful metaverse. My name is Joe Ferraro, and I'm the Vice President of Global Sales at Labster. As the leading education platform for immersive science content, Labster is helping to build the educational metaverse every day. In fact, today, more than 3 million students at over 2,000 schools, colleges, and universities around the world are using Labster. Our science simulations, they bring learners into an immersive 3D interactive learning environment. They allow students to work through real-life scenarios, understand relevant theory, interact with advanced lab equipment, and perform experiments while assessing learning with in-game quiz questions. Labster's always embodied the metaverse thinking. Even before COVID-19 drove textbook publishers to adapt all of their content for the web, Labster knew that interactive, gamified science simulations were the future of science education. So let me share a quick few facts about Labster. First, all of our simulations are developed by scientists, curriculum designers, and game developers. All of our simulation content aligns with high school or university curricula, and we build our simulations using the Unity game engine. That's the same technology used by major studios for popular games like Call of Duty. We are where students live. Labster was born as a VR science education company in 2014. We soon discovered that we had to accommodate the technical limitations of our users, and many users and many students just didn't have adequately powerful computers or access to VR headsets. We realized we were a bit ahead of the demand curve, so we pivoted to focus not just on VR technology, but also offer web-based simulations. The most important thing for Labster was to follow our primary mission, and that is to increase access to world-class science education for all learners, regardless of their socioeconomic or geographic backgrounds, and give $1 million lab to every student that wants access. And that's why this moment is so exciting. Even as I speak right now, Labster is investing in the newest VR technologies. We're evolving along with the metaverse. Look, we know you can teach science with a paper and pencil. Images in a textbook are a little bit better. Video can be better still, but immersive technology, that's a huge leap forward for education. I don't know about everyone here, but I'm old enough to remember being excited about the CD-ROM glued to the cover of my high school physics textbook. I also remember the feeling of disappointment when I popped that into my computer and I discovered that all it contained was more worksheets and more study guides. It wasn't that fun. Labster is designed to have the opposite effect on students and get them excited about learning science. It's possible to watch a class lecture. You can watch from the back row of the room. You can watch a video recording. But it's not possible to just sit and watch in a simulation. You have to participate. And that's where Labster's co-founders, Mads Bond and Michael Jensen, were inspired by that idea. Students playing video games don't just have to have fun. They learn. When he was teaching at the Technical University of Denmark, Mads noticed that his students knew more about famous football players and their strategies than they did about science. Labster was created to engage those students and pique their curiosity about science in the same way that those video games engage them to learn more about their favorite sport. That is why Labster uses game-based learning. Our simulations are fun as well as rigorous. And 96% of our university customers agree that Labster helps engage their students and improve their learning outcomes. Even more significantly, recent studies that compared students' learning outcomes before and after using Labster found student scores increased by 1 letter grade with Labster. We're proud to see that, and we're super proud that students everywhere are learning deeply using our simulations. When you think about it, there are facilities at some of your institutions that many of your students will never have access to unless they go for their PhD studies. Most colleges and universities can't provide access to a sophisticated lab equipment or costly reagents to any undergraduate who has an interest in molecular biology or in chemistry. Luckily, a student can perform all of those experiments using the same tools in a simulated environment. The experiments can be performed over and over again until the techniques are mastered, all without concern for waste and without having to schedule time with scarce equipment, supplies, and teaching resources. In Labster simulations, learners never have to leave the environment, even when they need to perform a calculation. We provide their avatar with a functional calculator in-game, just like they would have in the real lab. Reaching for an in-game calculator is natural for students who've grown up with video games. This is a direct parallel to role-playing video games, where characters have a set of tools that they bring with them to face challenges. Metaverse experiences like these are democratizing, not just for learners, but also for educational institutions. I mean, this is the ultimate leapfrog technology. Just like mobile communications overtook telephone cabling in the global south, there are regions without large educational budgets that can now provide first-rate teaching and learning experiences to their students, all in the metaverse. Just think about it. A graduate student in a remote area can participate in a discussion group with global peers without ever having to leave their home. A promising physics student can have access to an experimental particle collider in another part of the world. A pre-medical student can observe robotic surgeries and actually practice those techniques in a simulation. There's so many possibilities to advance education, and everyone here at Labster are passionate about helping to realize them. Listen, curriculum development on any new platform is by definition experimental, but the way that you can involve professional educators and scientists minimizes the risk and guarantees better learning outcomes. It's not just game designers, it's not just scientists, it's not just instructional designers. This is the team that needs to collaborate among all stakeholders to create the synergy that's needed for the content that our students require. There are so many educational games out there that make learning content secondary to the fun, and that result is stimulating but not educational. It doesn't have to be that way. Education in the metaverse can't start as a VR game and then just tack learning on later. It has to be planned from the beginning if you want it to succeed. In-world evaluations have to be meaningful, and especially in STEM fields, the learning must be demonstrable in real life, or IRL as they call it in the metaverse. And this has been successfully done in some fields already. Think about flight simulators. They train airplane pilots and astronauts. If a flight takes 7 hours, that person's going to spend 7 hours in the simulator monitoring all the instrumentation, looking out the window, looking at the turbulence. They can manage problems like changing runways at the last minute. They can survive failed decisions that lead to crash landings and learn from them in order to avoid it happening in real life. The key to bringing real education to the metaverse will be providing vetted, sophisticated, substantive curriculum to the students. The experience must be derived from scholarship and provide, at minimum, parity to traditional education. Students deserve a world-class experience. But teachers have limited resources. I believe that just like most teachers currently use textbooks that have been written and approved by subject matter experts, many of the features of the metaverse must be built by these experts. This includes experts in game design and programming, but most importantly, education. There's a place for creative teachers to do their own work, and there's a place for standardized material to make sure everybody's learning the same fundamental body of knowledge. That's why engagement with universities and educators like you will always be important. The metaverse is not just about creating these customized avatars and joining MMO societies. Sure, they're part of the platform, but what's most important is what you can accomplish within the platform. What will make the metaverse more than just a Zoom isn't just making it interactive, but it's giving challenges and more programmed objects that they have to complete. A meeting of avatars, it's really just a meeting until you give them that context of a scenario where they hold the roles of public health experts, and you give them a challenge such as a viral outbreak that they have to address. Suddenly, your students are a team of scientists, and they're solving a problem together. They're bringing their knowledge to bear. Learning experiences have to be as well conceived as video games, and they must go beyond this standard to leverage knowledge that students have from their prior coursework. It's all about scaffolding that knowledge and applying it to future learning. And going forward, education needs to use game technology to present these active learning scenarios. Labster creates simulation content where you can do all kinds of things. Anything that you can imagine can be studied in the metaverse, even better than IRL. We can look at things like time constriction, so you can see the results of a lab in moments. A crystal may take 100 years to precipitate from a given solution, but in Labster, you can see it happen instantly. You can see it happen over and over again. Time dilation, where you can actually do things like slowing down electrons around an atom so that we can see them at a human time scale and look at subatomic particle interactions. We can suspend the laws of the universe, which students have been doing in video games for my whole life, and let them do what's impossible in real life in order to learn from it. IRL, you can't stick your finger in a nuclear fusion reactor to see what type of power you're feeling. You'd hurt yourself. But in the metaverse, you can. Realistic physics engines, where objects react like they would in the real world. How fast will your avatar slide when she steps on a banana peel? How fast will she slide when she steps on ice? In an immersive environment, learners can quantify the comparison as well as experience the action. Builders of the metaverse will make all of this available to the people who engage in it. And that's why the continued development of the metaverse will continue to enhance the realism of interaction so students and teachers alike can comfortably communicate via voice, gestures, and expressions. In the ubiquitous global metaverse, the lines between education and work, they're going to be blurred. Today's students already participate in multifunction teams with their online games. They apply soft skills like collaboration, running meetings, and managing squads. While they're in school, students will be able to benefit from interactions with guest lecturers who are at the top of their field, regardless of where they are in the world. They'll be able to collaborate with their peers everywhere on different projects, academic research papers, and of course, laboratory experiments. And when these students enter the workforce, they're already going to be fluent in tools of business like live 3D whiteboards with data analysis and graphing functionality, as well as writing and visualization functionality. These are the fundamental skills upon which employees are going to layer lifelong learning. In the metaverse, anyone who wishes to advance in the workforce can quickly do so. They can acquire new skills via non-degree micro-credentials. They can enroll in a MOOC, or they can go for a degree from a global university. What we're calling the education metaverse today is what we're going to call education in just a few short years, and we want to make sure that it's fun. But we also want to make sure that it can inspire deep learning, offer opportunities for assessment and feedback, and inspire a critical lifelong habit of critical thinking. But the view of the future is not going to happen automatically, and in some ways is at risk. The challenge to educators now is to put away traditional lectures, stop the use of clickers to force student participation, and start demanding, expecting, and in some cases creating content that's more than just an activity in an e-textbook. Educational institutions, together with the edtech industry and companies like Labster, need to collaborate to put in the effort, the leaps of imagination and intellectual vision, and the financial investment to build learning experiences that leverage the highest potential of the metaverse. Academia must embrace the metaverse technology now. The education community cannot be afraid of the patina of slick, flashy technology. There's no such thing as technology that's too advanced or too useful for our students. And let's face it, if we don't meet them in their preferred environment, we're going to waste this opportunity. Facebook and its competitors will own the educational metaverse by default, and they'll use students' attention and valuable personal data for commercial purposes first and learning outcomes second. We all must partner to create learning experiences more like real life and even better than IRL, but always have the goal of solving global challenges rather than simply increasing advertising revenue. Thanks for your time today, and I'll see you in the metaverse. We can make it the best thing ever if we do it together.
Fantastic. Thank you for sharing about Labster. That seems to be really a wonderful platform, and many people would probably benefit a lot about using it. So thank you again for sharing about it. The last speaker is Dr. Jussi Kajala, CEO and co-founder of 3D Bear, a company that leads education technology using augmented reality. 3D Bear provides a digital solution for supporting creativity among children when using augmented reality. Dr. Jussi Kajala presents today some use cases of inspiring content creation in various educational fields using virtual and augmented reality, and presents the impact of these technologies on education.
Hello everybody, my name is Jussi Kajala. I'm the founder and CEO of 3D Bear, and today I'm going to talk about virtual learning environments using virtual reality and augmented reality and their role in education currently and what is going to be in the future. But before that, let me just introduce myself and the company I represent. So we are 3D Bear. We're a global category leader in XR for education. So if you, for example, search for remote learning in App Store, you'll find our logo in the middle. We are part of this global XR collection. We are Bill and Melinda Gates top 8 company in the world in XR in education, and so on. We have offices in New York, US, in Helsinki, Finland, where our headquarters are, and in Bangalore, India. Personal background, I've got PhD in theoretical physics. I went to University of Cambridge in the United Kingdom. In Finland, for 3 years, I led our national industry in 3D technologies in Finnish Funding Agency of Innovation. There I met my co-founders and we built 3D Bear. Our idea is that we provide virtual learning environments using AR and VR and everything it takes for schools in vocational, higher ed, K-12 to take them into use pedagogically right. So we are an integrator, a whole service provider in terms of virtual learning environments with VR and AR. We have also our own technology, 3D Bear app, that we use as a part of the process, in addition to partner software. What's really going on in the field of AR and VR in education is that during COVID-19, the kind of skills that require hands-on or artistic approach, they are very difficult to teach remotely. So you can teach mathematics, you can teach literature, theoretical skills over Zoom or Moodle or what have you, but how do you run a scientific experiment in Zoom? How do you teach how to cook? You don't get to kitchen. And these are the exact problems that virtual learning environments have provided an answer for during COVID-19. It's been like war, and this new technology has emerged, and now people are able to graduate using VR and AR environments, whereas they otherwise wouldn't be able to. Let's look at some examples. And the big trend in this technology during COVID-19 has been that people are at home, they cannot access campus, so technology needs to run on a browser or a mobile phone without specific equipment. And these interactive VR environments that are based on 360 images and interactive AR environments that are based on 3D objects have become like mainstream in education in developed countries. And let's take a look at some examples so you see what they're about.
In this simulation, the student gets to practice repair operations in a factory setting. First, the problem is introduced. The tank is empty. In the control room, the student can get better acquainted with the factory through the process automation system on the wall. There are hints embedded in the simulation that can be found by clicking on different objects. Safety at work is also taken into account. The door can be opened only after using hand disinfectant, and safety glasses must be put on before moving around in the factory. The student's task is to find correct valves and switches in the factory and choose whether they should be on or off. If chosen incorrectly, the student gets information on the operation of the particular valve as well as the whole factory. After finishing the task, the student returns to the control room, where the final task is to turn on the pump. The simulation ends where it started, in the tank, which is now filling.
And let's immediately take a look at another example in the field of healthcare, so you get the grasp of how these interactive 360 simulations work.
In this simulation, the student practices the tasks of a home care worker during a home visit. The simulation starts at the home care office, where the student prepares for the visit by checking the client's information on the client list and collecting the required equipment. Student progresses by answering quizzes on what should be done next. One of the student's tasks is to observe their surroundings. Clicking on different objects opens quizzes, and answering correctly gives points. In this scene, the task is to choose the picture representing the correct way of measuring blood pressure. Taking care of client's hygiene, an essential part of home care, is addressed in helping the client take a morning shower. Finally, the visit is registered together with the client. After completing the visit, the student evaluates their learning experience and the impact of the simulation.
So we looked at two different examples in VR simulations, which are accessible remotely. and which can teach you skills that you couldn't otherwise learn when you don't get to the workplaces or in the learning environments. So in the factory setting, you could practice maintenance operations in a factory, in a team. So there's a person who can be in a control room, who's the controller of the factory, and then the field repair team, and they need to communicate and solve problems in a kind of a escape room setting in a VR. And in the another example, we looked at the social and healthcare setting, where then you could practice the necessary skills in vocational training to perform elderly care home visit right. And both of these are examples that really enable you to learn something which would normally require you to do the actual thing in real life. And how great is that? Time is short, so let's look at some AR examples straight away. And here is arts exhibition example. I mentioned that the two main uses for VR and AR are basically for VR, having access to where you couldn't, and real-life simulation in hands-on and artistic skills. So this is an example of artistic environment. And this is two student groups from Tartu Kunstskola in Estonia and Pekka Halonen Academy in Finland, who had the task of creating a virtual arts exhibition because they couldn't organize a physical exhibition during these times. And what they did is that they created a 3D model collection of their artwork and published it through this mobile app so that anybody in the world could access it and play with it, interact with it. And that enabled great things. So let me just show some of the students' work. The theme was anamorphic art, and it's like these kind of pieces of art, and if you turn them around, look them from different angles, you see a shape forming. Or here, this is a opinado, it's 3D modeled art, and if you turn it around, you find secret messages that are answers to opinionated questions. So the exhibition visitors on mobile phone get these 3D pieces and they need to solve these puzzles created by artists. So in fact, we actually created a new form of anamorphic art in 3D. And so what happened is that some of the work was 3D scanned, some of the work was 3D modeled, and the students learned how to create this 3D. They learned how to create a virtual arts exhibition during this whole process. And then the visitors were able to really easy way on their mobile phone to put these models anywhere they want. So here's like, in traffic circle, a cat, a piece of art designed by somebody in the other side of the world. Here's, the opinado and that. I encourage you to visit this page and look in more detail what happened during this virtual arts exhibition. An example in K-12 space, this is student participation. Students were involved in local urban development by having them to give suggestions how would you improve your local surroundings. So they went to the local metro station and had some ideas how to develop it. This specific student groups, they put a watch here because they thought that, we should be seeing the time, but there isn't anything, there isn't clocks, there isn't watches, so we need to have one. So they're putting their idea here, taking a picture of it, and boom, sending it as a, tweet saying that, this is how we should improve our local metro station. How empowering is this? These are some of the students' ideas that they had regarding how to improve their local environment. All right, and what's really important here is that the examples that I showed, they are not ready-made content. They haven't been deep-coded in Unity or Unreal. They have been developed by teachers themselves. So creating AR, VR learning environments is now as easy as it's doing PowerPoint. The question is, what do you put on the slides? And with that, teachers need help. They need this co-development process where somebody walks with them the whole process of creating one great learning environment. And after that, they get the skills to modify, to change, to create new AR, VR learning environments. And that's what we were really doing. So for example, one customer has now created 500 different virtual learning environments. 120 teachers use this in one site only. And we started with one, and that happened. And that's really what's going on. But let's just talk about a little bit about the benefits of virtual reality and augmented reality next. So what VR is really used for is that you get an access to place where you couldn't access otherwise. So you get to these real life environments, you get to the laboratory, you get to the workplace, and there you can, in simulation, do the thing that you would do if it was real. So that's the really big benefit of virtual reality. Additionally, so this also saves cost, saves travel expenses, and so on. But additionally, it enables humble failure. So you can learn from mistakes. Something can blow up and it doesn't kill you. You can learn from mistakes in a safe environment. Secondly, it can speed up experiments. So for example, chemistry, you can do a thing that you need to be doing to kind of set up a chemical reaction, fast forward an hour, and then immediately do the next experiment. But what's important is that you shouldn't be building just immersive spaces in campuses to run these experiments, because if they go to the school, they should be going to the lab on the workplaces to do things for real. That's still more powerful than do it in VR. So the real benefit comes from accessibility, that you can do it at home. And that's enabled by browser-based VR currently. In AR, the pedagogical benefits are different. So the real benefit is interacting with the environment. The whole point with AR is that you see the background. You can do things with the environment. So students can themselves be in the scenes. They can, do plays in drama. They can do documentaries in media classes and add AR elements. And you can, for example, do the art exhibitions. You can do the design, product and service design that was demonstrated in the examples of students redesigning a metro station. So it's useful for product and service demonstrations as well that require seeing the real background behind you. It helps kinesthetic and visual learners to flourish. And finally, there's Bloom's taxonomy, which says that creation is the highest form of learning. So when you create something, let's say a historical scene or a cultural scene like Halloween here, you learn more from US culture than you would be learning when you just read about it or just a teacher explains it. So that's obviously powerful. I will finish off with the implications of what we've discussed on the education innovation plan. So VR is ideal for diversifying learning environments, especially in vocational training. Enabling hands-on and artistic skills teaching, which otherwise wouldn't be possible. This is must-have. If you need to learn these skills and COVID-19 prevents you access, this is the only way you can do it. And that's why the organizations and countries who strategically invest in this gain competitive advantage. Regarding AR is more like nice to have at the moment, but specifically it helps in enrichment. And I think what is really important is that if you teach AR, you need to be teaching 3D design, because real competitive advantage in AR comes from you creating the content. It's not you looking at the content, it's you creating the content. With that, I thank you, and I look forward to your questions.
Thank you for a very insightful presentation. And thank you also for our audience for having seen this keynote session. It was a time to learn how the metaverse and immersive technologies can be used in education and what potential they hold for the future. Now, the speakers from the keynote session will have some time to further discuss in a moderated session. We expect that the metaverse has a potential to create innovative learning environments. Let's then start now discussing the future prospects and educational usage of the metaverse technology.
All right, so welcome back for this moderated discussion session. So this is Andrea Bianchi. I would like once again to thank our speakers, Mr. Bongju Kim and Professor Woon Tak, to join us live today here in the studio. And also, I would like to thank also our Joseph Ferraro and Yussi Kayala to joining online remotely. So we start the Q&A session. I would like to ask volunteers in the audience to ask a question to the speakers. So please state your affiliation before I should ask any question, and then to whom your question is directed. Due to time constraint, I might also ask to the speakers to restrain the answer to about a couple of minutes. So let's see who has a question. Who want to break the ice today? I'm trying to see if I see anybody in the audience. I think I see Kalenzi. Would you like to ask a question?
Thank you very much, Dr. Bianchi, and thank you so much to the panelists for the wonderful discussion. My name is Dr. Kalenzi Cornelius. I work for the KAIST Korea Policy Center for the Fourth Industrial Revolution. So very, very, very nice discussion. My question goes to Mr. Bongju Kim. Mr. Bongju Kim, currently the discourse related to the metaverse technologies span over many topics, including technology, the contexts ranging from avatar meetings online to planning online virtual societies. And this creates a lot of confusion when trying to envision the direction of metaverse for education. What do you think are the key aspects of the metaverse that are relevant to the education? Thank you very much.
Right, like you said, metaverse discourse is very complex, and we are having hard time to focus on what should we do with this new concept. So we need to focus to achieve what we need in this educational environment in metaverse. And so I would like to say a couple of things, like we can get some immersion from the metaverse technology, and then we could also use the self-reflection or the self-referential aspect coming from the data collection of a student. So let me explain each aspect briefly. The immersion could give some purpose for the learners or the students. We are thinking that the educational achievement could be more beneficial if the learners are not focusing on knowledge itself, but for the actions that he admitted to do, like a hero in the world who in danger, like I said. So if students can believe the context and the environment, and then he should overcome or solve the problem for the world, and then the all of his action or learning actions are could easily embody the world, more physically interacted with the knowledge he needs to learn. So immersion is a very important aspect of the metaverse technology. And the other thing is, like I said, the data collection and the insight from the data itself. We could easily collect all the data that the students are, the students is experiencing in the metaverse world. So if some teachers cannot notice the students' action or feedbacks, but the metaverse environment can get it. So from it, we could easily understand what these students is good at or they're bad at, and then we could guide him or she or her on the best way to practice what he needs to learn.
Thank you for the detailed answer. Any other question from the audience? I see Ojuan. Would you like to ask the next question?
Yes. Thank you, Professor Bianchi, and thank you all the panel speakers for such a wonderful speech today. Hello, I am Juano, a junior student in Industrial Design Department in KAIST. While listening to the forum, I wanted to ask two questions to UC Kayala from 3D Bear. So my first question is, why do we need augmented and virtual reality in education? Are traditional face-to-face methods not good enough?
Thank you. And thank you also again for the opportunity to speak in this prestigious forum. So I think traditional methods are good for teaching theory. Virtual reality provides a way to access experimental or practical environments you could not access otherwise. In them, you can demonstrate or apply theory, and also over normal lab experiments. They provide a way to experiment in accelerated fashion or to experience humble failure. The laboratory can blow up in a virtual reality experiment. Augmented reality provides a tool for collaboration and interacting with the environment. It's better than traditional methods in digital storytelling and the subject you study, demonstrating products and services, or visualizing school projects in K through 12. So it basically enhances teaching higher order skills. So in a nutshell, VR provides you access to experimental or practical environments where you can simulate phenomena or any activity, and AR provides you a tool for collaboration and learning higher order skills.
That's fantastic. I think there was a second question from Juwon. Would you like to ask that?
Yes, thank you. Also, my second question was, if you had the power to decide, how would you improve the educational system with the usage of AR and VR technology?
So that's a good one, and one that I also passionately feel about. At the moment, ready-made solutions are not good enough for teaching anything seriously or comprehensively. So you cannot just buy AR, VR school book or online course and hope that it will take care of all of your teaching or educational needs. The key, really, I believe, in successful implementation in AR and VR in national education policy, and I think actually Finland is a very good example of this. So the key is co-creation with educators. The AR, VR platforms have become so easy to use that they are as easy as PowerPoint to create your own AR, VR teaching content. You've got to teach the teachers how to use these platforms and co-create content in them. And then the question is no longer how you use this AR, VR PowerPoint, but what do you put on the slides, the educational content. So if I had the power to decide, I would start implementing a national AR, VR content co-creation program with easy-to-use AR, VR creation platforms and educators. I would use solutions that students can use at home and don't need extra equipment. And in K through 12 space, I would start with science labs.
Awesome. We're going to get in very good question from the audience. So any other question? Any other question? Oh, I think I see somebody raising their hand. Yes, go ahead, Ekaterina.
My name is Ekaterina. I want to say thank you to all the panel speakers. I'm a graduate student of KAIST in the Department of Civil Engineering, and my question is to Mr. Joseph Ferraro. The question is, due to coronavirus pandemic, many traditional educational channels like face-to-face classes have been replaced by online equivalents. This caused a great interest recently in Metaverse and virtual reality technology applied to the field of education. Do you think this interest towards Metaverse technology for education will sustain beyond the pandemic?
That's a really great question, Katerina, and thanks so much for having me at this event today. It's been an interesting 18 months. So many students have been displaced or disrupted due to COVID-19.
And I saw a stat even from KAIST's president who noted over 1.6 billion students globally have been disrupted in the last 18 months. So whether we like it or not, this is the beginning of a drastic shift, one where students no longer need to be constrained by time and space and can actually learn anywhere. So simulated learning, AR, VR, these have always been tools in our toolkits for some time, but now it's really coming to the forefront. And whether students are participating virtually in a group discussion just like this, or working on highly scientific lab experiments with peers around the world, institutions are thinking about this a lot. I speak to faculty and administrators alike every day who are trying to find ways to give their students a world-class education. And what they found is technology's gotten to the point where the digital divide between some of your more well-established brand name colleges and universities are going to be facing competition from schools around the world that are going to unlock all these new technologies and have options that are going to be more localized and more affordable for. So I think the box is really opened, and it's going to be really exciting to see where things land from here.
Was there a follow-up question from Ekaterina as well?
Yes, I have another question, and the question is, what would be a suitable strategy to attract interest and increase the demand of educational content for metaverse or virtual reality platforms?
Yeah, this is a really great question too, and we've got to think about it. Education, it's a commodity. It's about supply and demand, and if institutions want to attract students, they need to have the content and the programs that interest them and meet the demands of the changing job markets around us. And content is the key to that. Whether it's co-creation, as was mentioned before. I mean, I look at Labster's partnership with Arizona State University from a few years ago as a prime example. We developed the first fully online Bachelor of Science in Biology, where all of the labs were run in virtual reality. And it was the first school in the world to offer this. I mean, flash forward a few years later, you're seeing incredible interest from schools around the world in offering similar programs. And this is going to continue. Even in the US, 1 in 6 students are taking at least one course online where they're using virtual courseware. And we're going to see how that evolves in the coming years, whether it's nursing students having access to labs at home or science students collaborating around the world, as I mentioned. I think we're on the forefront of a revolution where students are going to start to learn on their own terms when they'd like to. And schools need to be listening to what the students are hoping to study because they need to have the content to prepare them.
I think we have time for a few more questions. I see other people raising hand in the audience. Is Chigu, is it correct? Do you have a question?
Yes, thank you. I'm Chigu Lee, a first-year master's student in Department of Civil and Environmental Engineering in KAIST. Thank you, Dr. Wu, for your insightful presentation, and I have a question for you. I assume that immersion and attention may have an important role in education. If that is the case, what should be done to build an immersive virtual education environment?
Okay, that is a very important question, but it's not so easy to answer. Immersion comes from the various factors. For example, the interesting story can give immersion. Interaction can give immersion. Also, realistic scene reproduction can give immersions. Technically speaking, immersion, in the viewpoint of realism, we only can reproduce visual shape and 3D sound. Still, the haptics, smell, and the taste might be unsolved area. In order to give full immersion, we have to fully recover the human's sensation. In order to 5 senses, there might be other ones. The question is, how can we reproduce such kind of sensation in virtual environment? Also, the other presenters mentioned, content authoring is another important issue to give immersions. Looks like a Lego style or PPT slide style. The authoring toolkit might be pretty much important to generate immersive content on the fly. That's my answer on the question. Yeah.
Can I have something about
yes,
it?
please.
Okay. So there needs to be 2 perspectives. One thing is for the technological aspect, and then the other thing is content design aspect. And then the content design aspect, it consists of two elements like stories and system. And then the story gives you purpose, and the system gives you some space to interact and making dynamics from it, from the environment. So if we combine them together and get some synergy from it, and then we could get some context of the world story, and then it could help you to make some immersive world environments, I think. Yeah.
Thank you. I have a kind of follow-up question. And let's say I want to ask this question to each one of the speakers. So maybe we're going to do a round here from my left and then so on. So as an educator myself, working in traditional university, I found that the face-to-face component tends to be important, not only between the teacher and the student, but also between student and student, like especially when they work in group. But now that we do classes online, that is missing. So my question is kind of has two aspects. One, is this face-to-face component really important or not, or is it just an impression I have? So is it important? And if is it important, then what can we do in the metaverse to keep this component? So what do you think?
Oh, that's another difficult question.
Thank you.
In order to reproduce the students in the classroom as if they are exist in the same space, that's very challenging in the technical viewpoint. First of all, every household cannot have a studio, only have one camera. Is it possible to generate the 3D video avatar using the 2D camera? That's very challenging. Still, we can do it using the deep learning. However, that's very challenging. Also, in face-to-face communication, eye contact is pretty much important. But we can meet students through the camera. The eye contact is missing in that process. Then the question is, how can we recover the eye contact even when we reproduce the students in the avatar format? There are so many other difficult questions that's still, in the research domain, I think.
Thank you.
Right, and then my personal, I could share my personal experience. Like recently, I tried to use workrooms from the Oculus, the Facebook, and I had some numbers of meetings in there, and then I could experience the eye-to-eye contact with other people's avatar from it. So there was a kind of a touching for me, and then because the other services could not deliver that kind of eye contact experience. And so that I figured out that even if Metaverse is not exactly like a physical world, actual world, but it's the closest technology that could deliver the physical world until now. Like it's different from the flat screen, and then it's different from the keyboard and mouse. We could use a lot of human actions and human, lip sync or the facial expressions in that space, virtual space. So I think we could have some, evolve in there, and we could utilize it. Yeah.
Thank you for the insight. Maybe now UC, can you actually comment it out?
Thank you. Absolutely. So there's a hierarchy of needs. The metaverse is not going to help first to get students online and connected. So that needs to be taken care first, obviously. So student needs devices, they need internet, they need a camera. So in Bronx, in the beginning of COVID-19, students were taught over TV channel because they didn't have devices to be online. In Finland, 95% of the students already had everything they needed for online learning. So when you meet the kind of a first step in that hierarchy, then you can have Zoom or Teams and Google Classroom and and then you can have communication like we have now. Eye contact, facial expressions, you see what I'm doing, and I think that's really important. What Metaverse really adds on top of that in this kind of a third layer in this hierarchy, I think is fantasy and role play. So you can take forms of different characters and you can be somebody who you are not.
And this provides new pedagogical teaching opportunities.
Thank you. And Joseph Ferraro?
Yeah, so communication and collaboration, they're key in any environment. I can tell you, it was even in my role trying to do Zoom for the last 18 months. It took a little bit of context, so we all had to figure it out. And I think that it's the same in the metaverse. And students are going to have to find ways to interact with one another. I mean, that said, video games have been bringing people from around the world in a variety of ways for a long time. And I'm of the opinion that this generation of students is actually used to that already. And they're adaptable enough to find a way to continue that collaboration with the tools they have at their disposal. For them, it's not simply just doing an assignment like it might have been for me when I was a student. It's a rich environment where they can and should interact with everything around them. And it gives them an opportunity to really play that role and play something outside of just touching the screen, where collaboration and kind of being part of that team is intrinsic, and they're just going to understand it. So I think this generation's going to have a much easier time than I might have.
Thank you all, actually. I'll steal another question from the audience, but maybe we have to keep it a little bit short. The question actually would be, I guess, more on the business side. Beyond VR, beyond augmented reality, how can we expand the metaverse? Like, what's beyond? How can we expand the ecosystem of a metaverse? Maybe we can keep the same order?
Actually, my definition on metaverse is the extended virtual world that is connected to the real physical world. That means in order to connect between physical and virtual, we need IoT, high-speed network. We sometimes need the digital twin or artificial reality. Then we can expand based on our creativity. Another important thing is somehow we can feed the experience, knowledge in the metaverse to the real physical world. In that sense, we need the augmented reality. All those things should be go together to provide the more immersive experience in real and virtual world together. So the ecosystem-wise, contents, platform, network, device, all are pretty much important. Another important issue is the social issues. How can we accept use space? We didn't experience such a space yet. However, that is pretty much close to our daily lives. So we have to prepare such kind of the new experience. That is pretty much important to expand metaverse in our daily life.
Okay, I think what you did to expand our metaverse or metaverse ecosystem, I need to focus on the experience itself, because even if we could have a structure or the economical ecosystem in there, but the most important thing is the students or the users. So I think this is learning from the game design process. We need to make some kind of a prototype, and the prototype gives some experience that the users could play it again and again and again, and then we could expand the system and the context and the stories from the experience and the play model itself. So even if we could use the extensive technologies, and the future will tell us what kind of technology will bring us, but we need to focus on the basic element, the basic experience, and then we could expand a lot of services or the context from it.
So I think it's co-creation and content play at the moment. And in context of this policy, I think countries who support their teachers learning these content co-creation tools will have competitive advantage.
Joseph Ferraro, would you like to add anything?
Yeah, I think, I think that the metaverse is expanding on its own right now. It's not just AR and VR, it's NFTs, it's crypto. I mean, this whole world is starting to open up in front of us. I mean, just today, El Salvador became the first country to accept Bitcoin as an official currency. So I think what we need to do is actually, everyone on this stage right now needs to make sure that what it becomes is what we envision it to be, student focused, and making sure that it's built for the right reasons. I mean, the last thing we need is another Facebook collecting student data and monetizing it, because that's not going to get us where we want to be. We just need to make sure that we're all working together and make sure that the content is the king and that the commodity isn't the student, but the actual product that we're putting out.
All right. Thank you so much. We reached the conclusion of this discussion. I would like to thank again our speakers that join us today physically and also remotely. I would like to thank also our global audience for having attended and provided questions for us. It was a very valuable time for me. I learned a lot. So again, thank you all. So now, before wrapping up, we want to listen to the closing speech of Son Hoon, who is the director of Global Strategy Research Institute. I hope you all have a wonderful day today. Thank you so much.
Hello everyone, my name is Hoon Sun. I'm the director of KAIST Global Strategy Institute. I'd like to thank all the audience for watching the forum until the last minute. Also, I'd like to express my special gratitude to President Kwang-Hyun Lee and our GSI members who made this forum possible. I hope that this forum was productive and we all learned something new about the Metaverse technology. Oh, what a surprise, Nopchugi. Why don't you say hello to everyone?
Hello, my name is Nopchugi. I'm KAIST mascot. Nice to meet you all. I enjoyed watching this forum, full of interesting ideas. Oh, by the way, one question just popped up in my mind.
Oh, what is the question? Go ahead.
Well, I was wondering how our university would plan to use the Metaverse technology.
A great question. KAIST is working very hard to advance key essential technologies for developing a Metaverse platform and to incorporate Metaverse technologies with future education. Our ultimate goal is to become one of the leading universities in this field. For example, we are developing a virtual KAIST campus in the Metaverse platform with a variety of contents for supporting education, research, and student life at KAIST.
Oh, great! I want to be the part of the virtual campus and interact and communicate with KAIST members.
Of course, there will be something to look forward to. Let's say goodbye to everyone.